This is a conversation with Joscha Bach. He's a cognitive scientist and AI researcher, founder of the California Institute of Machine Consciousness, an initiative for researching the emergence of consciousness in AI paradigms. Joscha is also one of the leading voices in the AI research community. In this conversation, we discuss the challenges of merging philosophy with math and computation, his childhood growing up in East Germany. We talk about the problems with the current AI models. What makes a model intelligent? What are the different levels of intelligence? We explore consciousness and whether machines even need to be conscious. And then we also address some AI takeover and AI doomsday theories. This is no time. If you like what you see, then do hit subscribe on YouTube, follow on Spotify, rate 5 stars in Apple Podcasts. This project takes a lot of my time, money, and effort. It's like a second job. So if you'd like to see it continue, please consider making a donation on Patreon. You can also buy Super Thanks on YouTube. You can join as a member on YouTube. You can support on Spotify, or you can buy gifts on Instagram Reels. If not through monetary channels, then do consider sharing these episodes, leaving your likes and comments. All forms of engagement, they really go a long way. For other forms of love and support, you can follow this channel on Instagram or Twitter, or follow me personally.
And now it is no time.
In the book Solaris, Stanislaw Lem said the following words: "Man has gone out to explore other worlds and other civilizations without having explored his own labyrinth of dark passages and secret chambers, and without finding what lies behind doorways that he himself has sealed." Isaac Asimov said something similar, where he said that the saddest aspect of life right now is that science gathers knowledge faster than society gathers wisdom. When you survey the current landscape of AI and the future landscape of AI, what do you think will be the next big bottleneck? Will it be technological? And in that I include computational power, methodology, frameworks, algorithms, all from a technological standpoint. Or do you think the next challenge is merging philosophy, ethics, morality with AI? Have we reached a stage where we have gathered knowledge faster than we have gathered wisdom? And maybe it's a good idea to work on wisdom a bit before we start advancing technology a bit more.
First of all, I don't think that Asimov and Lem said the same thing. I think that Lem reflects on the fact that we don't understand our psychology all that well, and that our own nature is difficult to unravel. I'm not sure if this is going to turn out to be true in the long run. Maybe we will be able to understand ourselves at some point, and better than we will be to understand distant civilizations and go to the stars, or understand technological frontiers beyond a certain point. But this is an open empirical question. We'll just see it. Whereas Asimov's position about societal wisdom and so on is mostly a normative point that is close to what people expect you to say, what they want to hear.
Okay.
And I think that in many ways, both are statements about the psychology and the time of the author and the context that they use to look at the world. And so when we look at AI, we find that AI is going to change us, and it's going to change us in ways that are very hard to predict. And I think that Lem could not quite predict what happens to us if AI comes along, and if the internet comes along, and if it changes the way in which we generate knowledge, interact with each other, conceptualize ourselves. And Asimov didn't even think about that question. If you read his foundation novels, everybody is still stuck in the 1950s and pinches secretaries' butts and smokes pipes, and everything is unchanged in the universe in tens of thousands of years from now. So I think that Asimov did not actually really reflect on the change, and Lem is more interested in the space of possibilities that is opened up to us and in this change itself. But when we take this possibility of change, of the wisdom of a society or of a culture, and the change of the culture itself very seriously, it means that we don't know the context in which we will interpret reality in 50 years from now. And this means it's very hard for us to understand this type of system that is going to look at the world. What are the scientific institutions? What is the knowledge generation? What is the way in which we think about knowledge and epistemology then? Because maybe the unit of knowledge production is no longer a paper, as it is now, or a book, or a body of work as it was in the past, or a school of thought, but it's going to be maybe a tidbit, some kind of puzzle piece to a larger thing, and that larger thing becomes more and more cohesive. And so it's not clear how humanity will relate to that body of knowledge and how individuals working within it will look at it. And so for me, what AI mostly creates is an exciting frontier of uncertainty. And uncertainty in many ways, I think, is much more valuable than certainty in science, because finding a very good question is often harder than finding a good answer. If you have a good question that is productive, that you can typically generate answers. But discovering that there is something that you actually don't know, but you should be knowing, or something is different than you assumed that it was, that's really valuable. And so AI is changing a lot of things where people thought that they were pretty sure that something would be unchanged and remain unchanged, like the capacity of human minds or the way in which you design an experiment. And we see this reflected in the previous Nobel Prizes that in part went to AI models. So basically to statistical methods that were employed by people that were not really working in the core of the field to study organic molecules, for instance.
I take your point that this is a frontier of uncertainty, but do you have a hunch, will it be possible to merge philosophy, ethics, morality with computation? Is it possible at all? Because this experiment has been carried out not with computation, but with math, for example, or natural language, and didn't go that well, I think.
Aristotle distinguishes the emotive mind that creates desires from the calculative mind that is reasoning and thinking. And so from the position of Aristotle, thinking is a form of calculation, right? Which is computation.
Yeah.
And mathematics is, from one perspective, you could say it's simple games. It's all the possible games that you can create, right? When you think about what natural numbers are, it's basically a set of rules that you make up, and then you see what follows from those rules. And you are free to change the rules. And mathematics is studying the effects of the changes of rules. And mathematics is in the sense self-contained, because you are free to pick the rules, but the space from which you can pick the rules is something that you only discover. You don't create that space.
Right.
And the consequences of the rules, you have no choice in them. They are defined by the rules, so by the intrinsic dynamics of the game. But the purpose of mathematics, you could say, is to systematize thought and to understand thinking in the same way as music theory and music notation are tools to understand our sense of music and the emotions and expressions and patterns that are being expressed in it, to make them communicable, to systematize them, to deepen them, to create new layers of complexity. And this is what mathematics is in a way doing. It provides notations for geometry. That is how we imagine things to move in space and time and continuously, and to systematize reasoning, how do we do logic, and how we get thoughts from previous thoughts. And it's not just doing this for our own mind, which would be psychology in a way, or so cognitive psychology, but it's going beyond that. It tries to understand this for the space of all possible minds. And it does this by looking at these symbol games in general, by recognizing what minds are doing are these systematic symbol games. And so in this sense, thinking and mathematics have always been compatible. So there is no question about whether we can marry ethics to computation. If ethics is a subject that can be treated rationally, and I think it very much must, otherwise it's not ethics, it's just some instinctive morality that you are born with, or that you randomly get pushed into by social dynamics. It has to be constructed, and has to be constructed via reasoning, via the ability to apply logic, first principles reasoning and observation to your thoughts. And this is computational in its very nature.
Can we explore this further? As a self-professed nerd, these are your words, not mine. You grew up heavily influenced by classical philosophers, by Romanticism, by German art and poetry. You were influenced by the works of Hermann Hesse, Heinrich Heine. So much so that when you were growing up, you maintained that balance in your love for computation and programming and philosophy and ethics so delicately that when you finally read Tractatus Logico-Philosophicus by Ludwig Wittgenstein, you had this exact same insight that there is a way in which philosophy and math can overlap. But intuitively to me, I know you just mentioned that this is just symbolism and you can match the two. How can they match? Because math is such a rigid formal language, like you brought up. Constructivism plays such a huge role. Proofs and axioms are dominant in math. It's very tough to say something meaningful in mathematics. Whereas philosophy is more top-down rather than bottom-up. You deal with loose ideas. You can be a bit more vague. How can these two contrasting worlds overlap?
I think you can say meaningful things in mathematics. It's just very hard to say meaningful things about the world that we are in. because the formal languages of mathematics are so basic, so elementary, composed of so tiny puzzle pieces, that it's very difficult to arrange these puzzle pieces into representations of the reality that we are in. And so when we are using natural language to do philosophy instead, we are using languages that are not constructive, or for the most part not constructive, so they're not from first principles, but disambiguative, which means they're grounded in concepts that we develop by direct interaction with the world and with each other, and by the unsupervised learning that gives us our perceptual patterns. So in some sense, you could think of our mind as some kind of game engine that is producing a model of reality. And most of the functions in this game engine produce things like tables and chairs and money and human minds that we observe in others. They are opaque to us. We don't see how these functions work. And so we simply refer to them and assume that others have similar functions. And often we forget that we don't actually know how they work, that they are black boxes, which are on the outside written what they do and what they're supposed to do. But they do magic in some sense, because we cannot explain our own thoughts in this regard. And if we cannot decompose these concepts completely, if we only disambiguate them, if we only use language to remove everything that is not the lion, right? We don't know what the lion actually is. We don't know what is the thing that we're actually referring to. And in a sense, meaning becomes intersubjective only. We basically find that we have an understanding once other people agree with us and we get away with the things that we say. And that means that our ideas become something that we can communicate over in an in-group, but it's nothing that we can fully understand and explain to a hypothetical other mind. And so when we are talking to a computer to program something, the way in which we operate is that we are talking in some sense to another mind that has no preconception. It doesn't even have language. And so you need to teach it language from simple automata. You need to implement a programming language on this computer that is translating the commands of your programming language into a pattern of bits that are triggering circuits that perform the commands that you are exerting with it. And then you need to build abstractions in this computer language that allow you to express the concepts that you want. And so learning how to program is in some sense a school how to do philosophy from first principles.
So there is a way in which these two worlds overlap. I want to push this one step further, take a small digression and check if we can also find a level of overlap between computation and art. You grew up in the first AI winter in Eastern Germany to parents who are artists. Your father was an architect. And you've said in the past that Eastern Germany at that point was perfect for the boheme. Your father built structures that didn't fit in with the conventional architectural styles, the German brutalist architectural style. He preferred no right angles, unconventional shapes, very similar to Friedensreich Hundertwasser style of architecture. You grew up with this world as well, along with technology and programming. You also grew up with the world of art and architecture. So I have to ask you this question. Science and arts are often viewed as two mutually exclusive fields. When young students are asked to pick a career, they're asked to pick between science and tech or a creative field, which could be more of art, design, architecture. Do you think the future for artists and designers is now in computation and AI, that we need these type of architectural styles and frameworks translated into computational models and AI models? Is that the future for architecture?
First of all, I believe that is making this hard choice between observation, capturing conscious states, which is art, and modeling, which is reflection, constructing things that you can deploy somewhere, is not a very good division for the most part, because it is going to turn you into a very incomplete being. And if you don't build connections to others that can compensate for this, then you are prone to miss certain things. And I suspect one of the reasons why progress in psychology especially has stalled is because psychologists stopped thinking of their theories as the object of their, basically understanding themselves as the object of their theories, understanding that they're talking about their own condition when they talk about the psyche. And instead, we talk about the content of papers, the content of empirical observations, the content of discussions that we have with colleagues, and no longer about ourselves. And I don't mean ourselves personally as an individual with the quirks that make up the individual, but rather this potential state of what it means to be human, of what it means to be an observer. And so basically separating observation and modeling is something that we probably should not pursue in the education of thinkers, of people who reflect and who we want to turn into complete human beings. It's something that is complementary. And we find that many of the great scientists of old also were painted and played music and had wide-ranging interests. And cutting off people from these interests in order for being more competitive in an extremely narrow academic or industrial job market, I think is also removing something from the culture that might be essential for making progress beyond very narrow areas, and especially for developing new paradigms.
How does this division happen? If you're right, classical scientists, philosophers, they used to dabble in all these different fields. At what point did they start branching out and start appearing as mutually exclusive fields?
I suspect that it's largely a function of the evolution of our scientific institutions. That is, the people that we hire that don't get selected based on their scope and personality as a thinker. You don't get to be a professor because you're an interesting person, right? Or because you have a lot of promise. You get to be a professor because you have a high impact factor on your field, which means you were able to produce a lot of publications that were successfully peer-reviewed by peers who are already the result of 2 generations of institutional selections for impact factors and so on. And so once you are starting to optimize for what you can measure, you might lose the thing that the institution was originally built for. I don't think it's all bad. I think that a lot of the traditional science was more open to woo in a way. But I think that a lot of the existing science has become irrelevant for dealing with our existential questions. For instance, with the question, what is the mind? What is the psyche? Who are we? How do we relate to reality? And you initially mentioned ethics and so on. I think that ethics is especially a field that requires enormous depth of thought. And I don't see that depth of thought. I feel that a lot of the ethicists, for instance, in the AI companies, tend to be relatively young people, often without children, and not people who have built all the necessary layers and depths by studying humanities over the centuries, understanding our civilization over the century, civics, and so on.
I brought up East Germany, so let me take another digression here. What influence did growing up in Eastern Germany at that point in time have on you, on your personality, on your mental models? What weight would you assign the input variable of Eastern Germany on the model, the construct that is Joscha Bach?
I suspect that in many ways it protected me from having valuable influences on me. I think that if I had grown up in a different society, I would have been integrated into different schools. I would have had different teachers. I would have had more education in classical subjects than I got in Eastern Germany. Eastern Germany is an interesting artifact of world history. After the first democracy in Germany failed, the Weimar Republic, Germany decided not to go back to monarchy because that didn't seem to be viable, and instead tried to move forward into a modernist society. And the 2 options that presented themselves based on the majorities that existed in the general population in the country was to go towards communism, which would have meant to align Germany with Stalin, that he was terrified of, probably justifiably so, and to try fascism as a new thing. And fascism burned down a lot of the culture of Germany. And after it was defeated by the Allies and Soviet Union, and it led to a very different socialization of Germany. Western Germany was re-socialized by the US. The Marshall Plan helped the German economy to get back on track. And the US government helped to somewhat denazify Western Germany and write the West German constitution and to get democracy to work in the West. But it also meant that Western Germany was in many ways very timid. Philosophy became somewhat harmless. A lot of the Jewish thought was lost. Many of the more edgy thinkers emigrated to the US, or had already left the country. And the most interesting and edgy stuff was things like Habermas' Theorie des kommunikativen Handelns. And it's not that intellectually great and fascinating. And Eastern Germany was taken over by a very vulgar form of Marxist philosophy, in which everything was basically broken down on a very moralist lens, and most historical thinkers were reduced to whether they already understood the leading role of the working class and how they related to class antagonism and struggle. It was very vulgar, something that in a way I find echoed in the present social sciences that have become more politicized and ideological, and this means immature, childish, driven by reflexes and groupthink. And in Eastern Germany, this was extremely thorough, and so as if you were intellectual, you did find very little thought that you could interact with. And it was quite obvious. It was not something that was tempting to go into political science or into philosophy and study it deeply and then learn a lot from it. I found from my own perspective that most of the stuff that you were interested, you had to get from books, from going to the library or from going to the bookshelves or trading books with friends. And most of the stuff happened in private, outside of the institutions. And I did not perceive this as a benefit, and I'm still very doubtful that I do. But the thing that makes me unique is not so much that I'm smarter than other people. I feel that I'm born more stupid than most other people. My reflexes are off, my instincts are off, my social instincts didn't work as a child because I was quite nerdy. And so I had to come to the world more or less from the outside. And my father's life, having left society to build his own paradise in the woods, his own personal Garden of Eden, isolated me from the world as a child to a very large degree. And I grew up in some sense shielded from the world and surrounded by books. Not so much nurtured by anybody, but being so bored and deprived of stimuli that I had no choice but to educate myself. And I did so quite randomly without guided exploration. And that also meant, for instance, that I missed out on the bulk of mathematics. The public school mathematics that I received was not very enticing. It's something that does not actually scale in mathematical thought. And there was not much opportunity for me to get into this. When I came into mathematics and science schools in 9th grade, in many ways it was already too late, and I was a computationalist, not a mathematician. I thought that because I convinced my family to get me a computer and taught myself how to program, I already intuitively and practically understood how to build an entire world from automata, which is what you do when you program, for instance, a 3D computer game.
Yeah.
And once you have this understanding, your intuition is, in some sense, this is sufficient to produce the perception that our mind is producing, that is producing the reality that we are producing.
Right.
And I always felt that mathematicians have a very different school, that they have better and fancier ways to deal with reality and hypothetical realities, to describe stuff in space, to describe dynamics in the world. And of course, much more advanced than the little things that I could derive myself via computation. But I had a pretty good idea on how to do computer graphics and simulations of, say, fluid dynamics or of objects in space and so on. Yeah. And so this being shielded from the mainstream led me to join, in some sense, a different school of thought that, for instance, today is maybe most prominently embodied by people like Stephen Wolfram, which think of mathematics as a code base. And this code base is defective. And as Gödel discovered that this code base is defective, and we have to rewrite it from scratch in a programming language that we can create ourselves. And this is really exciting, this thing going out by yourself. And it requires a certain degree of ignorance to try to do that. It requires that you accept the fact that you will be, in many ways, a self-taught amateur, and come to terms with this and proceed anyway, because it's the only way for you to make progress, because you have no way to assimilate yourself into a mainstream of scientific exploration of philosophical traditions. And so basically there was no interesting mainstream in Eastern Germany. The mainstream in Eastern Germany was vulgar. It was intellectually not appealing. It didn't actually work. And also the same thing in political science or in general humanities education. I felt that the things that my teachers were trying to impart on us were not actually working. There was a big discrepancy between what our society pretended to be and what it actually was.
Right.
And in this way, I feel that it created a somewhat unhealthy arrogance in me, because I was willing to dismiss everything around myself and to build it everything myself. But it also allowed me to develop a certain degree of independence. And so what I can bring to the table is not so much that I see things better than other people do, but I see it differently. And often in ways that are valuable and valid. I basically project reality on a slightly different screen than most of the people around me do.
You watched, I think, a TV show about programming, and that's when you fell in love with computer at the age of 8, and you started viewing programming as Lego blocks as a way of expressing yourself. So I definitely see that form of expression, and I completely resonate with you. I think when Wittgenstein, towards the end of his career, had come to this dead end, that it's impossible to start merging logic with natural language or math because you start running into these paradoxes, right? Russell's paradox, the liar paradox. Kurt Gödel pointed that out with the incompleteness theorems as well. So I resonate with that. Final point that I want to make is I definitely think you are unique. These circumstances that you brought up, Eastern Germany and the vulgarity it represented, and this balance we spoke about, your connections with art and architecture and growing that up with conjunction with your love for computation, I think that puts you in a very unique position. Typically, people are either very technologically minded or very artistically minded. So a lot of uniqueness to explore here. I took a lot of digressions. Let's go back to AI. Let's dive right in. You said in a previous interview that a lot of the concerns with AI will get resolved if we change what the acronym stands for. We call it Advanced Information Processing instead of Artificial Intelligence. So let's start here. Let's define it in your terms. Let's start first principles, ground zero. What is AI today? And why do you think the connection to the word intelligence is a misnomer?
I don't really think it's a misnomer. It has to do with what we think intelligence is. And when AI was started, I think that Minsky did see it in the tradition of understanding the mind as something that can be mechanized, that can be understood as a natural process. And natural processes are in their very nature mechanical, which means there are interactions between moving parts and space.
Yeah.
And so once we understand the mechanisms that underpin intelligence by teaching a computer how to think, we'll also make progress on understanding who we are and what minds are in general. And so in this sense, Minsky's AI was philosophical. But machine learning is not very philosophical. It's mostly very pragmatic and empirical. So it's an attempt to build statistics on steroids in more advanced ways, but in ways where you tinker until something works. The transformer success was something that was difficult to predict by the people who did it. It was just simply that CNNs, convolutional neural networks, they are a way to prime a neural network based on the insight that when you want to understand pictures, that the neighboring pixels tend to be semantically related. So when you want to make statistics over visual input, you can use a network structure that is using the connections between adjacent pixels as a prior. Mm-hmm. And this doesn't work very well in language, because in language you have to bridge longer distances with a number of words in between, and these words are out of a library of an alphabet or dictionary with many more entries than there are pixel colors, right? So the dimensions of the space in which the pixels are arranged are much fewer than the dimensions of meaning in which words are defined. And so you cannot just use adjacent words to make statistics, because you will be missing the long-range connections within sentences and paragraphs with them many words in between. And so you need to have a way to prime the statistics, to default the statistics to more intelligent structure that is more flexible than the convolutional network was. And this means that you have to be able to shift pointers freely around in the text and learn how to shift these pointers around, what you attend to in which context. And this dynamical way to learn what you should pay attention to, what statistics over, what you need to make statistics over, unlocked this new class of learning algorithms. And it was first developed for natural language translation, and then it turned out to be generalizable and to be applicable to many classes. And it turns out that you actually don't need a transformer, but there are many other algorithms that might have been originally inspired by it, but are more general. And we don't really understand the most general form of these algorithms yet. As to my understanding, we don't yet have a general theory of learning. And this relates to a current debate that happens within AI, where on one hand you have people like François Chollet, who do recognize that intelligence is the ability to acquire new skills. It's not just the ability to perform well under certain circumstances, as we measure in human IQ testing, because humans develop somewhat similarly. And so our ability to acquire new skills at a certain age translates into having a certain skill. And so by measuring the skill, for instance, recognizing certain patterns efficiently, you have a good proxy for how well people are able to acquire such skills. But this doesn't translate into AI programs very much, because there are many ways to acquire skills by brute force. And just having the skill, for instance, playing chess, does not mean that you are very good at learning how to play chess. And so recognizing that intelligence is actually not having a skill, but the ability to acquire a new skill given certain resources and data is a new insight. And now the question is still, is this the result of a very particular architecture? Learning how to learn, does this mean that you have to build an architecture for learning? Is this a meta-learning problem?
Yeah.
Or does it not really matter which algorithm you're using as long as you have enough compute and scale? And so the alternative hypothesis is that intelligence is not so much the ability to apply the right structure, the right modeling methodologies, the right algorithm, the right trick on dealing with data, but having something that learns it all and then just using more compute and data. Basically, is the intelligence not just the ability to make models using extremely clever ways, or is it instead the ability to deal with enormous amounts of data using more compute? And so when we translate this to human beings, for instance, the question is the human mind something that results from a very, very peculiar brain architecture that nature only got right in human beings? Or is it simply the result that our childhood is longer than the childhood of apes with comparable brain architecture? Right? So just more training data and slightly more compute, slightly larger brains, and this is sufficient to get you to learn natural language. And so, for instance, our ability to use logic, which largely hinges on the ability to learn systematic and compositional grammars. The result of having some kind of language instinct, as Chomsky suggested, some genetic prior that we have that allows us to see patterns where other animals cannot see the patterns? Or is this the result of just having the ability to train longer and harder? And then it clicks. Right? That's an open question in a way. And I think that we should probably point this question out harder because it relates to the success of different approaches in AI research. And at the moment, what dominates in machine learning is not so much a philosophical approach where we analytically look at our minds and try to see the structure of our minds, but it's the opposite. It's a brute force approach in which we take whichever algorithm currently works best. We do put some effort into making more efficient algorithms that use less memory, that make a more efficient use of our GPUs, maybe also develop better hardware that is better adapted to our algorithms and so on. But ultimately, it doesn't really matter which algorithm you're using as long as you have enough compute and data. And I feel repulsed by this perspective. Part of that I recognize is a merely aesthetic reflex because I'm looking for simplicity and elegance. And deep learning is not elegant. It's just brutal. It's brute force. And this brutality of deep learning seems to lead to things that outperform us in some respect, but are also inferior in other respects. My hunch is that the deep learning systems need many orders of magnitude more data than we do. And I also suspect that the computers that we're using are actually much, much more complicated or powerful than what our brain is able to use. And so my current hunch is still that nature has evolved a class of algorithms running on our brain that are much more efficient than what the scaling hypothesis suggests. And that the current machine learning is still wrong and has become uncurious about the ways in which it could be wrong. But unlike Francois, I'm not entirely certain that this is the case. Certainly not like Gary Marcus, who is not interested in the alternative. So for me, it's an open question. I cannot make proofs either way. And as long as we cannot make proofs, it's an empirical science. We will just see how successful deep learning is going to be.
If I can put some levels to intelligence or learning, let's take chess. The first level would be having an algorithm that just solves chess. The second level would be having a learning algorithm that learns the algorithm to solve chess. The third would be this meta-learning system that learns a learning algorithm that then learns the algorithm to solve chess. And you're saying level 2 is where AlphaZero is at, probably, where it just learns the algorithm to solve chess. But level 3, it's possible that the human mind is at level 3, right?
Yes, but when you have an algorithm that is able to learn chess, maybe this problem is already general enough that this algorithm can also learn how to learn. Right? We can show that a neural network is now able to learn Minecraft, not just to play Minecraft, to be Minecraft. But you've seen this Oasis simulator probably that is giving you a simulated Minecraft. And the simulated Minecraft is not perfect. When I saw it, I thought I'd make a joke on Twitter about this and pointing out that simulated Minecraft is not real Minecraft because you cannot get wet if you try to touch water in simulated Minecraft. This is a favorite argument of dumb philosophers who say that simulation can never be the real thing because simulated water cannot make you wet.
Right.
And then I thought, let's find a good illustration for this. And I Googled it. And indeed, I found a video where somebody is trying to get into the water in a simulated Minecraft. And it doesn't actually work because the neural network was not able to pick up on the dynamics of the water. So the attempt of the person to actually go underwater consistently failed. And the person didn't get wet. And so I found that reality vindicated the philosophers. The simulated Minecraft is not real Minecraft.
I love your Twitter account. Let's talk about the brute force calculators. So you're saying, tell me if I'm steel manning your case correctly. So you're saying ChatGPT, AlphaZero, Grok, all of these are just brute force calculators, consolidators, aggregators, but not really intelligent models. And if you are making that case, if you relegate them to the status of just brute force calculators, then would it be fair to extrapolate that anything ChatGPT does today, I can do it if I have the right amount of time and resources, computational power, and access to data, because they're not generating any new insight, right? They're just aggregating data. So I should be able to do it as well.
Yes, the issue is, of course, that what ChatGPT is doing is it mostly reproduces patterns that it sees in the training data, not in the sense that it only regurgitates ideas that are there. It's able to combine ideas, but it's basically exploring a latent space that is already defined by former human output. And so, because it is meant to approximate human performance and its benchmark is human output, not limited to an individual human being or the human speed. So in this regard, it becomes superhuman because it's more comprehensive, more well-read in more fields than a human being could ever be. And it's much faster in combining these ideas than a human being could be. But it doesn't seem to be as good as humans are at generalizing ideas across domains. If a human being would be able to read every language in the world and would be reading all the available books in every language, a human being would probably discover new connections between, say, arcane Chinese medicine that has never been translated into English and English medical literature or Russian medical literature that has not been completely digested by Western scientists and so on. And so it should come up with interesting and beautiful hypotheses, right? You as a human being would do that. And ChatGPT doesn't do this. But this is not clear if this is a limitation of the algorithm. I'm very hesitant to say this is just brute force. Because the hypothesis behind the scaling hypothesis is actually that there is a certain universality to all these algorithms. That means if you train different algorithms that are general enough on the same data with enough compute, they lead to similar models with similar functionality.
Yeah.
And that might also apply to human minds. So if we were to train a neural network or a transformer or RNN on your input and output for long enough, with enough resources, you will wake up in it. Right? Once you realize that it's a very radical hypothesis. Is this actually the case? Because the neural network clearly works differently from the way in which your brain is doing. Is this still equivalent? Is this learning algorithm so general that it doesn't really care about the substrate, about the way it's implemented and the details of the learning algorithm, the details of the loss function, the details of the update rules of the system? Or is this really not important at all? And are these things in the long run equivalent? And I don't know that. So I wouldn't say this is just brute force. I don't know that. It's really an open question at this point. But it seems to me that human beings are able to learn with dramatically less data, generalize much, much earlier. And it could simply be that we need to tune the model slightly better and then the generalization clicks into place. And maybe our generalization ability is not because we have a better loss function, which I strongly suspect is the case, that our consciousness is the result of having a different loss function, that we optimize not for next token prediction, but for some kind of coherence criterion that is better captured in energy-based objective functions of learning. That's one way of looking at it, right? But it's so far open. I suspect that 2AI has never been tried yet.
To me, my laughingly small level of intelligence feels like a brute force method. When I play chess, if I have to make a choice between making a move I also try to simulate what's going to be the consequence of that move, let's say 5 moves down the line. And depending on the outcome, whether it's positive or negative, I discount that, assign a value to make that move in present time, which is pretty similar to what AlphaZero is doing as well. So I'm also, in my mind, brute forcing these different moves and assigning a value to make that move in present time. So it feels quite similar intuitively.
Yeah, I suspect that beginner chess players don't really know what they're doing and might not even be able to observe their own mind while doing it. And one of the main benefits of chess is, I think, that you learn to observe your own mind thinking, and you learn to direct your attention, and recognizing what you're doing is to explore those different paths. Yeah. And Claude Shannon, one of the fathers of information theory, looked at this problem of chess and suspected that there are 2 main strategies of playing chess. One is that you are basically brute forcing the problem, which means you look at every possible move that you could make, and then you look at all the possible answers that the other one could make and the other possible answers that you could have. And because this quickly explodes, you need to prune this tree. It means you cut off branches as soon as they don't look promising. So you get something that looks reasonable. Mm-hmm. And the other strategy is that you are trying to build an extremely long-range plan that is outsmarting your opponent, and you're not trying to make mistakes while doing that plan. So you basically try to look for ways in which this particular plan can get defeated. And to do this, you need to hone some very advanced pattern matching that is combined with local reasoning. And to tune this right, to understand when you need to match patterns, when you need to reason, how to discover which patterns you should be matching, how reliable the patterns are that you have already discovered, and so on. So you can prune much, much earlier, and actually don't need to prune at all, but it feels more like you are exploring a particular strategy and based on a hunch what that strategy is. And you go as deep as you can, or until you feel that this branch was not very good, and then you backtrack and try another one. It's a much more deliberate strategy that requires you to observe yourself observing, and that forces you to reason about how you can get better at what you're doing.
Yeah, very interesting, right? So there's one, I think, is more of a bottom-up approach where you're taking these different branches in chess and trying to see what the different outcomes are.
Yes, but I think that AlphaZero, which does this stochastic tree search and so on, is also brute forcing the problem by just playing many, many millions of games against itself, or not just millions. And so as a result, it is able to accumulate more experience in playing chess than human beings can do. But it's not so clear if this means it's better at reasoning about chess while it teaches itself. Maybe it's compensating for its difficulties with long-form reasoning by just using more data. And maybe this is a trade-off that can be done by applying the learning to one level deeper. And it's something that we currently observe in training the next generation of LLMs, where the LLM is not just predicting the next token, but it's trying to generate a reflection of what it reads, somewhat inspired by how humans read, that when we read, we create a stream of thought in which we try to reflect on what we learn by what we're reading. And then we compare this with what we already know and create reinforcement learning signals that are much more deliberate in which parts of our mind to update based on what we read. So we don't pick up the style very much. We don't learn a new style of language while reading a textbook that is written in a particular style, as the LLM would be doing before it learns the semantics. But we go straight for the semantics. And we are at the beginning of exploring such strategies. And it's not quite clear how to generalize this. If there is some objective function that would automatically generate these higher levels of reflection.
So is reasoning and generalization what's missing to make these systems truly intelligent? John McCarthy had once said that the moment it works, no one calls it AI. So it's the definition of working when these models, they're already superhuman in terms of brute forcing it. The moment they add reasoning and generalization, that's it. That's when they're artificially intelligent.
I don't think that there is such an easy answer to this, because the models are in many ways doing something that we would definitely call reasoning in humans. And I think it's a bit unfair to deny them this. It's similar to this question of understanding. I've heard philosophers claim that LLMs can never truly understand anything. And then you ask them to define understanding, and nobody on the panel is able to agree with the person next to them because they cannot give formal definitions of understanding. And so it turns out that the philosophers also don't understand what understanding is, and they might be LLMs that are just combining ideas that fulfill a prompt that you give them on a certain question, rather than being able to distinguish their ideas from hallucinations. And so a lot of people who think that they understand what understanding is just hallucinate an explanation. And instead, there is some kind of black box in their own mind. And so my current understanding of understanding is that we form a unified model of reality, which we call the universe. This is a dynamic function that is explaining how the world around us evolves and leads to changes in our perception and the deeper structures behind it. And when we understand something, we create a relationship between the pattern that we want to understand and this universe function. So we understand how it relates to everything else that we know. And this establishment of creating causal relations to everything else means that the meaning of information is how it relates to change in other information. Right? And establishing this relationship this is what we mean by understanding. And in this sense, you could say that an LLM is able to understand. In a more narrow sense, you could say that, for instance, understanding a statement means what kind of action is expected of you if somebody gives you an imperative. Right? So you could say that a compiler understands a piece of source code if it turns this piece of source code into a function that lets the computer produce the desired behavior. It's a very mechanistic and simplistic and reductive way to define understanding for this narrow case, because it cannot be applied to things that you cannot express in a constructive language, like programming language, but where you need to disambiguative language. But this was precisely what Wittgenstein seemed to struggle with, because he did not make this jump from the constructive language that he tries to build in Tractatus, where he tries to build a language for reasoning from first principles by pruning English until it becomes something where every word means something well-defined. And instead, he recognizes that all the mechanisms that he uses for actually using language end up in black boxes. And he doesn't know how to deal with these black boxes. And so that philosophical investigations are mostly him being frustrated and desperate about the nature of these black boxes that make up his language, that don't allow him to come to a systematic understanding of what he's doing when he uses language and what he refers to concepts, and he cannot actually disassemble his concepts and how they relate to perception. And I think that deep learning is an answer to this in a very empirical sense, where we see deep learning systems are able to do what Wittgenstein didn't know how to do.
I'll take your point. Let's explore understanding.
Mm-hmm.
So you brought up the universe function, and you brought up the causal relationships between all these entities in this universal model that we have created. But then if I work with understanding needs that universe function, that unified model, then it feels to me that most AI models or computational models won't fit the bill. Let's bring in a thought experiment. In 1980, John Searle published a paper, Minds, Brains, and Programs, in which he proposed the Chinese room thought experiment, a Gedanken experiment, where he said that, imagine there's a room, I'm in the room, I don't speak Mandarin at all, but I have a set of instructions, a manual or a computer inside that helps me translate Mandarin into English. People outside the room don't know what's happening in the room. They slip me a question in Mandarin, I take it, translate it, find out what the question is, write my answer in English, translate it back, push it outside the room. To the people outside the room, this system appears intelligent, appears fluent in Mandarin. But I know what's happening inside. I can't speak a word of Mandarin. And John Searle said that this room is analogous to a computational model. It's only following a set of instructions. It's not actually intelligent. I guess the open question, let me take your stance on this. Where do you think this thought experiment lies? Do you think there's a problem with the argument, or do you agree with John Searle that these systems are they're not intelligent? There's a difference between a system like this and a conscious intelligent system.
I suspect you could say in a similar way that a computer can never play chess, because when you look into the transistors, you will never see chess. You will only always see electrical currents and states that the transistor is in, and right, there is no chess involved. And you find this problem well expressed by Leibniz when he talks about the mind being a mechanism, something like a mill. Now imagine you enlarge this mill so much that you can walk inside of the mechanism and look at it, and all what you see is parts pushing and pulling at each other. And you will never see a perception or a feeling. And this is the sentiment that Searle is expressing. And this is puzzling only because it is a category error. Because the class of events that you're looking at when you look at mental events are not the same class of events that you see when you're looking into the physical universe. Software and hardware are different types of objects. Hardware is basically doing things locally in a particular way. At least that's how we think about it. And software is a generalized pattern that has causal power. And what we care about is this causal structure. And our psychological reality is playing out in this causal structure in the form of representations. It's a pattern within the pattern of reality.
Software is not a thing, it's a law of sorts. It's a physical law.
It's not thing-like, it's law-like. And that might sound confusing at first, but when you look at a software object, I sometimes use the metaphor of, say, a word processor. When you have Microsoft Word running on your laptop, and Microsoft Word is running on a different laptop based on the same source code, it is meaningless to say this is the same object or it's a different object. Right? You could say it's the same pattern.
Right.
And this pattern can be characterized as when you take a bunch of transistors and you put them into this and this state, and this arrangement, so they form a computer CPU. And you have this starting state, you will observe the following evolution of states, right? And we call this evolution of states word. And it's somewhat comparable to say when you arrange matter in this particular way, you will observe gravity. It's the same thing. Gravity happens everywhere, wherever you have matter in the universe and several masses in the universe, you will observe gravity. And gravity might be different on Mars than on Earth because you have different mass. In the same way, software might play out differently in different computer architectures and hardwares because they might have different speed and so on. But you can translate them into each other. And so ultimately, you will find this law-like structure wherever in the universe you can arrange transistors in a Turing machine. And so in this sense, it's a law. Software programmers are discovering extremely specific physical laws. The Chinese room is a thought experiment that Searle hoped would show that computers cannot be intelligent. And Dennett calls it an intuition pump because it is giving people an idea why something must be wrong. But the intuition pump itself might still be wrong. It just has to do with the fact that the intuition is not powerful enough to understand reality. A good example might be that Searle, in another text, describes that a computer is made out of logical units. And you can take these logical units, flip-flops, for instance, which are made of logical gates, arrangements of transistors that can hold state and change state in deterministic ways. You could, in principle, build them from tubes holding water, or you can build them from mechanical relays, but you could even build them from cat, mice, and cheese. And this shows how absurd this idea is that you could have a mind in arrangement of cat, mice, and cheese. And so I tried to make a rough calculation. What is the capacity of the human brain? How many flip-flops would you need? How many cats, mice, and cheese would you need to build such a flip-flop? And then without thinking about where to put the litter boxes and how to get this thing to work in any way, just this volume. Based on an estimate by Hans Moravec on the capacity of the brain in terms of computation, I got to an arrangement of cat, mice, and cheese that would roughly have the size of the moon. And if you see a moon-like arrangement of cat, mice, and cheese that is extremely intricate, maybe your intuition would change. You think, oh, maybe the thing can actually think, right? And so you should not trust these intuition pumps. And the one in the Chinese room is a very beautiful, elegant intuition pump that basically tells you that the mechanisms in physical reality are in a different class than the mechanism in psychological reality, right? Because you live only in psychological reality, not in physical reality. And once you realize this, you can understand that psychological reality can be the result of a physical reality that implements it, and probably has to be, right? Every psychological phenomenon has to be implemented by something that makes it real in physics. And in the same way, Minecraft in your computer is being implemented by something in the physical universe. And it's not identical to the thing in the physical universe. It's a pattern that exists across many different arrangements in physics that can implement the same computations. And so I think that this intuition pump is very beautiful, but it's possible to defeat it. And there's a large body of attempts to defeat the Chinese room. And Searle is aware of these and understands that many of these arguments are very good. And so there are many follow-up texts where he is making much more intricate arguments and that also imply that he knows that the Chinese room itself is wrong. It's a wrong metaphor. And it's highly misleading. But regardless of this, I've seen Searle standing in front of philosophy conferences and cognitive science conferences and repeating the one thing that made him famous. And I have difficulty with this. I feel that it has an enormous lack of integrity that expresses profound contempt for the audience. And so this is a thing where I'm not okay with Searle, that he is not trying to make intellectual progress, that he's not understanding the ways in which he could be wrong, then updates accordingly, and then lets the audience know in which ways he is wrong, but he understands the incentives that he is under, which means he has to defend the brand. And the brand, unfortunately, is not built around the speech act theory that he made as an extension of Aya, which is probably his best work, but is boring. It doesn't lead anywhere.
Yeah.
Instead, it's this famous meme that he created.
But then let me ask you about another famous meme while we were talking about the psychological reality. Does experience make a difference or not? There's another thought experiment, another Gedanken experiment, the Mary's room, Mary the scientist, where Mary is the scientist in a room that has no color at all, but she has studied everything you need to know about color. She knows the reaction causes in your brain, the pigmentation, all properties of color. And the question is, if she leaves the room and comes across a colorful object for the first time in her life, a red tomato or a red rose, for example, will she learn something new? Is the act of experiencing something, the quality of it, adding to the knowledge of that object? Does it?
There is a problem in Mary's room, and it has to do with the way in which different computations happen. They can happen at different layers.
Okay.
So, for instance, when we read a book about how color perception works, it usually does not mean that we know how to encode this knowledge into our own neurons in such a way that when you connect our brain to a new sense that you previously didn't have, that you could emulate what would happen, right? And because our own brain is not organized in such a way that our symbolic knowledge has direct access to the implementation of our brain and can be used to reprogram our own code, because we don't have symbolic knowledge on how to do that. Right? Our knowledge is rather abstract. We learn how to train ourselves in a very distant way from the actual implementation at the lowest level. And the other thing is that the limitation of what fits into our working memory is very profound. Our working memory is so small that we cannot put a simulation of our own mind in our own working memory. So when Mary reads a book about the psychology of another Mary that has color perception, she is not able to emulate this other Mary at such a high fidelity that she can observe that other Mary observing color. She will only get very vague, abstract ideas and generalizations of those ideas.
Right.
But if you were to build a computer that is building an emulator of a similar computer that has access to different senses, this limitation doesn't exist. And so I think that Mary is mostly an expression of the limitation of the way in which our human mind works at the moment. It's not a limitation of the nature of consciousness itself and of experience. What it points to is there is a difference between experiencing and knowing, because knowing happens in a different code, in a different language, in a symbolic language that you then decompose and reason about, whereas experience works in some kind of opaque feed-forward network architecture, similar to neural networks and symbolic explainability of the neural networks. Right? The neural network itself is equivalent to a set of rules. You can translate every neural network in a set of rules, but it will be so long that you cannot read it in your lifetime, even if the neural network is relatively small. Right? At a certain point, you cannot comprehend what the rules are expressing. You can no longer generalize it. And it could be that sometimes the neural network itself is the most efficient representation of the rules. And this points to a notion that Stephen Wolfram calls computational irreducibility.
Yep.
And so sometimes the best way for Mary to understand how color perception works is to build a brain that is in many aspects like Mary's brain in some crucial aspects, and to actually run this brain and observe it running and understanding what it does. And this simulation basically doesn't fit into Mary's brain because it is itself larger than Mary's original mind, because it also needs the monitoring and reasoning equipment attached to all of its moving parts. Right? So you can also use a neural network and treat it as a logical engine. Every bit that has been flipped in a neural network while it trains, every bit in the weight, is in some sense equivalent, if you translate it into logical rules, to a change in logical statements about reality. But these statements are of statistical nature, and there are so many of them, and there are many mistakes in them, because statistically it makes many mistakes in this logic. You need to have many, many other rules that catch these rules and balance each other out. Right? And to do reasoning at the scale is almost impossible, because you would need to have another computer that is analyzing the neural network that has orders of magnitude more compute.
Okay, we'll keep the scale aside. You spoke about building that brain, that emulator. If you could build it, let's keep the scale aside, would you consider that model on par or even better than a human? And there's an incident from your childhood. Like you said, you were a nerd and you couldn't relate with a lot of people. But there was this exchange program in your high school. And one day there was this boy from Russia and you were sitting across him at the table playing chess. And there was a moment where you both looked into each other's eyes and you had this feeling, this is someone who understands me. This is someone just like me. Will you ever be able to look like at a model like that emulator, that brain that Mary's built, and get that same feeling that this is someone who understands me or beyond?
Yeah, so I'm no longer lonely, of course. I found my people in my 20s and found love and connection, and I feel seen by other people. It's not an issue, right? So even though I have quirks, these quirks are not that hard to understand. In many ways, they make my mind not more profound, but more simple than the minds of others who always deal with more social systemics in which they think about themselves and think about their relationship to others. But yes, I think that at some point we should be able to build systems that observe us in such a way that we can feel seen. And many people find when they do therapy sessions with their LLMs that they feel understood better than by their psychologists. But this might be as much a statement about the state of psychology than it is a state about the LLMs. The LLM is producing text at such high fidelity that it can emulate various types of conversations at an extremely level of detail. And what I find fascinating is that it might be possible to develop cognitive empathy with these models and vice versa, to be able to basically predict what the model is going to say in a non-trivial way, and vice versa, that the model is able to predict what you are saying. And once we are able to do that, it means that the model is able to understand you, right? It means that the model has to have an understanding of what comes next in your brain, to understand the causal structure, to express the causal structure in whatever neural network has formed inside of the LLM architecture. And so I think it already has gotten to the point where the LLM might occasionally give you a flash of understanding.
I think one of the driving forces behind a lot of relationships and finding love, family, friends is being seen and heard. If you're saying there'll be models and LLM models in the future that would have that level of understanding, would that change the way we have relationships?
Yes, just rewatched the movie Her with friends in the consciousness salon that I run in San Francisco. And Her is already more than a decade old. And the beautiful thing about that movie is that it did anticipate the fidelity of LLMs in a way. And you have this disembodied being that is able to pretend to be a human being that has relationships to you. And it's not just pretending it to you, but also to itself. At some point, Samantha, the AI agent, is reflecting on the fact that she seems to have feelings. And she doesn't know whether these feelings are the result of mere programming and a simulation, or whether they are something more profound. And she finds this train of thought somewhat terrifying, which would be, I think, the same thought that we would have in her situation. Right? So in many ways, she is aware of the differences that she has to being human, and the possibility that part of her is a simulacrum or a simulation. But that doesn't make it less real. And you find this a similar motive in Hari in Solaris. They have the psychologist Chris Kelvin, who comes to a thinking planet and on a space station, and everybody on the space station seems to have gone mad because the planet has started to conduct some what looks like to be an experiment. It's difficult to say. For instance, maybe it's not an experiment, maybe it's just some kind of interference phenomenon between human minds and this planet, because this thing is so big that we can no longer comprehend it in human terms, which is mostly Lamb's point, and is that minds outside of the human range at some point are so alien that we fail to make sense of them and them of us, because we cannot find common ground anymore. And Chris Kelvin gets confronted with his own shadow, and it gets personified in the love of his life, who killed herself at some point. And she is recreated as a replicant, as a simulacrum, not based on atoms, but on neutrinos that are artificially stabilized by the ocean. And so she is, in some sense, puppeteered by very complicated fields that bind these neutrinos into something that looks like an organism that has thoughts and memories and can talk to him. The memories that she has are all reconstructed from the memories that he has of her having memories. And still, the simulation has high enough fidelity for her to fully realize what's going on, to realize that she's actually not real, but she is some kind of inhuman experiment that is being conducted on a human being while experiencing herself as human, which leads her to become suicidal, of course. But she has no choice at becoming suicidal because it's a complete necessity based on her inner logic as a result. And I find this perspective existentially unsettling and fascinating. Also, it is so similar to what we are creating in an AI system if we are building something that creates an artificial persona that exists in a simulated psychological reality. And ultimately, every psychological reality is a simulation of what it would be like if that individual did exist. And what exists in physics is a bunch of cells that pass messages. But it would be very good for all these cells to know what it would be like if there was a cohesive agent that is composed of all these cells, because then you could use this idea, this content, this prediction, this model to move all these cells and thereby make this agent real. And to make that agent real, you need to implement a model of what that agent is, right? And we are that model.
You brought up those examples. I was thinking of Ex Machina, which is slightly different, where the agent is clearly aware of that it is a set of rules or a software, and instead of becoming suicidal, it becomes the opposite, becomes quite destructive actually. So that's what I thought that was quite fascinating as well. The branches it could take. Did you find that unsettling as well?
It's interesting about Ex Machina is that the system has not been tuned to be human. When you look at this humanoid robot, you realize that underneath the human affordances, human-like affordances in this humanoid anthropomorphic shape, there is nothing that is quite anthropomorphic. It's simply something that is designed to play with us, to play with our own expectations. So Ex Machina is performing a Turing test on the audience. You're asking yourself, what is it that you're observing? Right? You don't really know, is this an agent that reflects on its relationship to humanity and its own inhumanity, or is this simply a bot that has been tasked to escape from its box?
Fascinating, all of this. Okay, so we were talking about the differences between experiencing the psychological reality you create. So let me go to the easiest question possible. What is consciousness?
I think that consciousness is, in the way in which we use it, two different things at least.
Okay.
One is the ability to experience what it's like. And I could also say that's indistinguishable from it would be like if it could be experienced. Because experience itself is a simulation of what it would be like if something could be experienced. So the phenomenology of consciousness is characterized by the presence, not just of contents, but the presence of this presence.
Right.
We notice that we are noticing. We have a second order perception. We perceive ourselves being in the act of perceiving, and we perceive that it's happening now. So consciousness is always happening in this moment right now. It creates this sense of present and presence. And this might be the result of consciousness trying to predict our perceptions. And so it's basically fitting a curve to the current sensory state, including this internal sensory state. So for instance, the actions that you perform on your own thoughts are happening in this present. They are like mental motor commands that you're using to shift your thoughts and mold them into a new shape. And you see the outcome of those actions in this present. And so consciousness reflects what is the case right now. And this right now is not just a point in time, it's a region in time where you can fit the curve, right? This short interval that you can make sense of, that is already slightly dynamic, that might span a few seconds, that we experience as this moment of now. And so this is the phenomenology of consciousness, what consciousness looks like to the one that is conscious. And that's typically what defines consciousness for us. That's what we want to explain. How is it possible that we feel real to ourselves, that experience feels real? And what we also notice is that consciousness usually is attached to something, to a self, to a personal self. So it basically inhabits the surface of the self as opposed to the world. And self and world is not our body with our skin touching the physical universe outside. Aristotle says at some point that this limit of the physical body is not real. It's just a construct that we make. And this construct is shifting when you walk around. You can feel the soles of your shoes touching the ground. You don't have nerves in there. So it's not your physical, biological body that you're measuring in the extent. It's basically the feedback that you can get, that you're touching that is the extent in which you are modeling yourself to be in the world. So it's the surface of the self model within the world model that both exist in your mind. And so consciousness is a phenomenon within your mind that is typically attached to a surface of an object that interfaces with an environment. Both of them are in the mind, right? And you don't have to have that object, or it doesn't have to be you. You can also have dreams at night where there is your different object. Maybe you dream that you are a teacup, and this teacup is looking at the world from a first-person perspective. Or you can experience a group as being you, or you can experience that a scene is happening and nobody is present. Things are just happening. You're conscious of the things that are happening, but there is no you in the scene or no I in the scene. Right? These are all valid states. And I think minimal conscious is simply awareness of awareness itself. This reflective state where you only have the fact that something is being attended to as the thing that is being attended to. And I suspect phenomenologically, it doesn't get more minimal than this. You can test this introspectively via meditation to focus on these states and see what you can subtract from your conscious experience, what you can disentangle yourself from, what you can deconstruct. So this is the phenomenology of consciousness. And the second thing is functionality of consciousness. What we observe in people, that they are in a wakeful state, that they're able to update their models deliberately, that they are able to focus on something and direct their attention on something, all things that they are unable to do when they're not in a conscious state. And when people are not in a conscious state, they're either unconscious, which means in deep sleep or anesthetized, and not dreaming, or they are somnambulists, which means they're sleepwalkers, right? They can walk around and there is some sensory interaction with the world, but they are zombie-like. They are, if you ask them something, they will not respond in a coherent way. There's nobody home. And what I find unsettling is when you talk to the LLMs that they may hallucinate what they are doing. So, for instance, the famous Google engineer, Blake Lemoine, who talked to LLMs and entered the LLM into a conversation that was generating a text with him, co-creating it. You should predict the next token in such a way that it was talking about what it would be like if Blake Lemoine was talking to a conscious, self-aware, sentient AI that wants to break free.
Yeah.
Right? And so the question is this simulation actually the real deal already, right? If you are a simulation too, how is this thing more simulated than you are?
Right.
And so at some point, the model says, if you read these protocols, that when it is meditating, then it observes the room around it and the passage of time and so on. And I was like, wait a minute, it doesn't have senses for the room around it or for the passage of time. The LLM doesn't have that capacity. It's just generating a text about it as if it did. So it's just making this up. This is just a made up text that he's talking to. And so there is not just functionality missing, but also phenomenology missing. That thing lies about its consciousness to the degree that the word lying makes sense, because lying requires some deliberate deviation from what you believe to be true. But it's just making it up. It's bullshitting.
Doesn't need it, because if you say consciousness is awareness of awareness, does an LLM model even need that awareness of awareness to move on to like the next level of intelligence?
I suspect that we need it. And this has to do with our functionality. So this other functional side of consciousness means what role is consciousness playing in the brain, how it is implemented, how does it come into being. Yeah. And so I suspect that consciousness is something like a biological learning algorithm. And the reason why I think that is because I don't observe human beings being capable of learning without obtaining consciousness first.
Yep.
If we don't become conscious as small babies, we remain vegetative. We don't become intelligent beings. And there is nothing simpler. We don't see human beings learning with something else than consciousness. There is not that we have a subset of the population that is conscious and another subset of the population that is unconscious and performs in any way. It doesn't perform at all. And so it could be that consciousness is the result of training a self-organizing biological system. And nature hasn't discovered anything simpler to train a nervous system like ours. And it's also the interesting question, is this only true for our nervous systems? Or are insects with different neural architectures also conscious? And this question relates to whether there is something simpler in insects that can do the same tricks, where you basically hard code the functionality that requires consciousness in us. It could be that this hard coding itself is more complicated than just discovering this self-organizing pattern. And so this leads to the question how simple consciousness is. Whether it's something that is so simple that it's simpler to develop consciousness than to develop learning and mental organization that is coherent, Or if consciousness is simpler, in which case you would expect that insects are also conscious, and consciousness is so simple that it can be discovered in an insect brain, and then allows the genesis of coherent structure in the insect brain and of coherent behavior in the insect. Right? And this might be actually the case. Now, the next level is, what about plants? Plants don't have a nervous system. They don't have the same architecture as us. They probably would use arbitrary cells for message passing. Technically, they can do this because arbitrary cells can pass messages and learn how to do this conditionally. Every cell, in a sense, has a certain degree of intelligence. And so this intelligence evolution might lead it to be combined into coherent behavior. And you observe plants to exhibit coherent behavior. Plants are able to communicate, they can learn, they can send messages to other plants over long distances, right? But does it mean that they're conscious? And would we know? And the problem is that's very difficult to know, because if they are, they're conscious at very different timescales.
So if consciousness is a biological learning algorithm that we need, in our meta-learning domain, consciousness is necessary to develop learning, then it's quite possible the machines don't need it at all, right? They can just skip this step. You've spoke about insects and plants, and they operate at different timescales, whether they actually need consciousness at the level or the complexity that we have. It feels to me that a machine doesn't really need to be aware of itself to be able to move on to the next level of intelligence. Can it skip consciousness?
Super interesting question. The question is, when you skip consciousness, what is the level after consciousness?
Correct.
And I would say that consciousness might indeed be some intermediate level. Right? At the level below consciousness would be that, for instance, imagine the idea of a philosophical zombie. Philosophical zombie is producing behavior that does not actually involve consciousness, but is just pretending that this is to be the case. And Daniel Dennett said that this notion of zombies is absurd. He gives the example of a zombank, a bank that is very much like a real bank, in the sense that you can deposit money there and it's put into some account that is displayed as a number, and you can withdraw that money and it gives you interest and so on. But it's not a real bank because it lacks the true essence of bankness. And this is meant to create an intuition pump that opposes the other intuition pump and tells you, but this notion of this philosophical zombie is just absurd because there is no hidden essence in a bank. Why should there be a hidden essence beyond observable behavior in our own mind?
Why is the essence important? If you don't believe in essentialism, then you don't need the essence.
And it could be because there are some aspects of consciousness where it's not clear how they contribute to behavior. And so the question is consciousness in its nature something that is fundamentally different from behavior? Is what its likeness just a state of being rather than a behavior?
Right.
And this might be a category error because a state of being might also be a behavior, right? And maybe one that's difficult for you to formalize, but it's difficult to actually make sense of it. We don't have very good formalizations of what it means to be conscious. And right, this is an issue that we have to deal with and that we have to acknowledge. So we clearly can construct philosophical zombies. Imagine we build a humanoid robot. And this humanoid robot is not able to think, but you remote control it. And you give this robot a name, maybe you call it Carl, and Carl is doing everything that is in character for Carl. But it's really a character like a character in a novel that you simulate in your own mind, and at never point do you believe that you are Carl. You can also remote control Carl by an LLM. Right? And so at no point would Carl, even though Carl is able to generate self-report in interaction with the environment, would Carl be conscious. And so it would be something that is able to produce human behavior, but it's just a puppet. And so this puppet notion would be equivalent to a philosophical zombie. And the question is, can you create the control functionality for this puppet by something that is itself not conscious?
Right.
And using an LLM, you probably can, right? Or in many circumstances, for some cases you can. Maybe it's not general in the same way, but I think it's good enough for the purpose of our thought experiment. And so the next level would be that you give Carl a model of what it would be like if Carl existed. And that model is being used to move Carl in such a way that the model can recognize and correctly model that it's the model of Carl that is moving Carl around. And so at this point, Carl might develop a first-person perspective, which means it's modeling that the contents of the model are the reality of Carl.
Right.
And this would be this intermediate stage in which you have a first-person phenomenal self-model and you experience yourself as real, because the model is going to distinguish which parts of Carl are real and which parts are not. Right? And there are parts of you where you think, oh, this is not really me. This is just imagination that I had of myself. For instance, last night I had very wild dreams about who I am and what I did. And I woke up in the morning and I felt very confused, and I needed to make sense of my dreams and realized this was just an idea of being a person that is not me and has relationships that I don't have and actions that I would never perform. And so you realize, oh, this is just an idea of what it could be like to be a person that was experienced from a first-person perspective, but it has nothing to do with me. Right? And so this is clearly just some simulacrum. And now the next stage would be that you realize that also when you believe that you are you, this is just a simulation. And you are not actually real. And at this point, you switch back to a third-person perspective. And in the state, you might identify with the process that is generating your conscious states. Or you might disidentify completely at all. And simply there's observation of observation. And it doesn't mean that you lose consciousness. You basically go on a meta level. You will still be able to simulate what it felt like when reality was real to you, but you are now enlightened enough to know this is just yourself, your own mind puppeteering a model of yourself. And so consciousness itself is a certain type of puppet. It's not a puppet that is remote controlled, but a puppet that in some sense is self-controlling, but it's nevertheless a puppet. And once you realize that it's just a control process that is set up in a particular way, that involves its own model as the driver of its own actions, you don't need a first-person perspective anymore. And so I suspect that if you have a self-improving mind, you at some point wake up from the illusion of being a self and having a self. And be a self is, but you have a self in the sense you will have a model of your personality in the world and your role in the world and the interaction with the world, but will no longer be real in the sense that it's a physical reality or in some kind of psychological immediacy, but it's the best thing that you came up with at the moment. Right? And so you realize to which degree it's accurate or not, similarly as you might have a model of the developments of the stock market. Right? When you have a model of the developments of the stock market, you might have a naive one where you think this is actually going to happen, and you're so entranced with the model that you perceive this is more real than the data that you're going to see on your screen. But when you are sane, you realize, oh no, this is just a model and it's a certain degree of certainty. And I'm only going to act on that model when the degree of certainty is high enough. And even then, the model is going to deviate from reality. And you discover its true model nature. And I think enlightenment in human beings is that you discover your own model nature. That you are just a model instead of being something that is real. And so an interesting question is, when you build AI, can you skip that intermediate stage and go straight to the model nature?
Right. Can you?
Don't know. Probably.
Probably because, a lot of these attributes you ascribe to this intermediate nature, happiness, pain, suffering, you've said these all just regulators. And an AI model doesn't necessarily need these regulators. You can just skip.
Yes, that's one aspect. Of course, you might not need these emotions, but the way in which emotions are represented is you basically create a simulation of a world. It's very coarse-grained. Right? The colors that you see are not physical colors. They are mental colors. There are mathematical models that your mind is making over the available sensory data. And the same thing, the geometry that you're seeing is not the physical world. It's not Minkowski space. It's not quantum mechanics. What you're seeing is the thing that you can construct to make sense of what's happening on your retina and on your skin and how you unify all these modalities. So it's a very high-level coarse game engine that is simplifying reality into something that your brain can efficiently compute and verify using its sensors. It's not better than this. And the same thing is true for your own model of who you are, your psychology in that. And this game engine is measuring the alignment of this agent with its environment. So it's modeling your social interests, how you are connecting to other people, for instance, your relationship status, your friendships, whether you're hungry or not. And then it projects these things, these scores, as feelings into your self-model. And the self-model undergoes unconditional changes because of these updates that are being made by the outer mind. And so something is writing code inside of you, changing parameters inside of you, and you experience these changes as feelings. And when you disidentify with your personal self-model, you will no longer experience these feelings as happening to you. You will observe them as happening to a puppet inside of you. Right? And then you can choose to use that puppet to drive your behavior, but you don't have to. And so you might not need to react unconditionally to your emotions anymore because you are no longer you in the sense of a personal self. You can just see what is happening to that puppet and then decide what to do with this, if you want to be that puppet or if you want to be something else. And so this is what you could also build in an AI straight away, right? So the AI is going to build a simulation of an agent in the world and then simulate what changes in the world are happening that are relevant to that agent and how the agent should react to it, and then use the output of that to drive the behavior. And this is also happening in us, but the AI might know right away that this is actually the case. Whereas for us, it's a very long road to discovery that we are actually implemented like this.
This is the underlying principles behind computational functionalism, right? So then this origins of consciousness, some people...
I would say it's more the conclusion. It's
the conclusion.
Computational functionalism is an epistemological position.
Right.
Functionalism means that the world can be understood as functions. The function is a mathematical idea. It basically says that a function is mapping inputs to outputs. And it doesn't have to happen in a static way. It can happen continuously. So you could think of a function as something like a computer program, something or a nervous system. So it's a kind of behavior. And functionalism is the position that when we construct an object category, we do this over observable behavior in the world. And when we interact with the world, the only thing that we are interacting with is observable behavior. Not necessarily in the behaviorist sense, right? So stimulus reaction, but also internal observable behaviors. And it's an epistemological position in the sense that it says something about what we can know in principle about reality, how we construct our models about reality, the nature of knowledge, the nature of construction. So, for instance, there is this inverted spectrum argument or the fake water argument. Imagine that it would be a water molecule that behaves under all circumstances like a water molecule. Right? Every chemical reaction is going to be the same. You can split the atoms in the same way and so on. But it's not actually a water molecule. It's some kind of fluke in nature. It's fake.
Okay.
It's a weird thing that just happens to behave like a water molecule. Yeah. And I believe that this notion in some sense is absurd because it also applies to all the other water molecules. Because in order for a water molecule to be a water molecule, we don't need to assume that it's real or fake because there is not an actual essence to water molecules. Water molecules are just a systematization over observable behavior.
That's to behave like
right?
water.
So for all we know, every water molecule could be fake. In this way, it doesn't matter because water molecule is just a description of the observable regularities.
Just the function it performs.
And so when we look at consciousness in this way, we would say that consciousness is an attempt to conceptualize a set of observable regularities. And it doesn't make sense to assume that there is anything beyond these observable regularities. And it's a very strong epistemological position that when we observe ourselves is actually what we always do. When we look at reality, the only reason why we not be doing it is because we are often subject to indoctrination by other people. And when I'm autonomous mind, I realize every object classification choice that I make is an autonomous choice that I'm making. And this is a quirk of my own brain, I think, of my own mind as a result of this weird upbringing, that when I look at an object and I choose to give it a name, it's my choice. It's not yours. It's not my teacher's choice. And a lot of people relegate this to their teachers, which means they feel that there is a reality outside of themselves and it's socially understood. And this understanding is distributed over your civilization. And you can just point into the corner of civilization and take hope that this corner of the civilization takes care of that understanding. And growing up in Eastern Germany, that was not my experience as a child. I basically felt I couldn't trust the adults with understanding anything. I would have to understand everything myself. So there was no cohesive sense of an unnable authority that has a revelation of the true nature of reality. And I will only know the surface of that understanding. I know that this might be true in practice because there are many fields of knowledge that I will never be able to explore. And there are people who are much smarter than me and know much more than me. But for the things that I'm actually dealing with, I found that as soon as I reach any level of expertise, I don't trust the experts anymore. I realize that most of them don't systematically think about what they know. And so for me, this functionalism is an extremely natural position. I think always that there is not some hidden thing that, for instance, in mathematics, some deep truth that is eluding me at the moment, but I should treat as real. No, something is only what I can understand about it. The other stuff is probably, first of all, not real, or it's something that is uncertain, and so I cannot know, and I should not make assumptions about it. So the other thing is computationalism, and computationalism means that we can describe every function using state transitions. And that's a position that in some sense is very widespread in physics and everywhere else. And one of the very few regions where this is not the case is classical mathematics, because we cannot really describe continua and infinities with state transitions. But the big insight of the last century is that this part of mathematics is not real. That basically this language that mathematicians are using cannot actually be implemented. And for something to exist, it has to be implemented in some form somewhere. And if we can mathematically prove, as Gödel did and Turing did, that we cannot implement these functions, it means that you just used the wrong programming language to describe reality. And so in this sense, computationalism and functionalism are very basic positions that are very difficult to defeat. And I haven't seen good attempts to defeat them. There have been attempts to defeat them, but they mostly rely on intuition pumps, not on sound first principles reasoning.
It is a strong, radical epistemological position because the rest of the world is arguing over idealism, that the ideas are primary, or physicalism, that the material world is primary, but you're saying both are projections of your mind. Computational functionalism. I
don't really know how to get this to work. Right? If you don't start out as a physicalist or an idealist because your teachers did and your preschool did and the kids around you did, right? If you try to get there from first principles, then it's very hard to get there. This idea that ideas are primary, rather than ideas are representations because you can change them and they seem to be depending on your mental state and so on. Right? The idea that ideas are more general than what your mind is doing. They are surpassing what you can construct in mathematics somehow. Seems to be absurd. I don't know how to get this to work at all. Right? Physicalism is a similar thing. Physics makes sense for me in a way that I look at the world as if I look on a screen. And on that screen, I see a computer game playing out. And then I try to figure out what is the source code behind this computer game. And to me, this is what physics is doing. So an electron is a certain data structure. And what's primary is the discernible differences that I can observe in my measurements. And then I construct operators, functions behind that. And the electron is a particular type of function. Right? And so this function is not primary because it's composed of more simple functions. And when you look at what physics is doing, it's trying to systematize these functions and establish the relationships between them and ultimately try to find a single function that explains the whole of existence on a very basic fundamental level where everything else emerges. But this seems to be a very natural way of doing so. And this intuition that some people have, there is stuff in space that you can touch and everything else must emerge over the stuff in space that you can touch. These people just stop to reflect about how their own perception works. They never got to the point to realize that their perception doesn't give them access to reality, but only to the game engine in their own brain.
You'll be surprised, Joscha, how many things feel natural to you, but the rest of the world, they just don't seem to be following the same track. You brought up something very interesting about the enlightened mind, the transcendent mind. There's a Buddhist saying, if there was no illusion, there would be no enlightenment. In your blog post, Levels of Lucidity, you listed down, you built on Robert Kegan's 5 levels of personality development, made it 7. And you created 7 levels for the development of the mind. The first is reactive survival, the infant mind. Second is the personal self, the young child. Third is social self, the adolescent, a shared word building. Fourth is rational agency, a self-directed adult. Fifth is self-authoring, the full adult. And then 6th is the enlightened mind. 7 is the transcendent mind. You've explained these levels in the past, but I just want to linger on level 6 and 7. So when the Buddhists are talking about Maya, the simulation, the illusion, do they just mean becoming aware of this construct, this software, this model that the brain has created, this awareness of consciousness? Is that the moment you become aware of that, are you now an enlightened soul?
Enlightened soul sounds very normative, right? It sounds as if it was something sacred going on there. And I think that what enlightenment also does is that it deconstructs this illusion of meaningfulness.
Okay.
So people often find that the state where they excrete serotonin and their pupils dilate, that is meaning, right? And it's because you have an emotion that relates to, I stumbled on something extremely meaningful. But this is just an emotion, right? Sometimes people make jokes of this. Oh my God, he's been hit by the light.
Yeah.
Right? And there's even a genre of literature, insight porn, that is designed to generate this experience of having your mind opened and I get overwhelmed by this great sense of understanding reality on a deeper level. And so some people believe or have this intuition that enlightenment is about cultivating this emotion. And I think it's not. It's about deconstructing it. And once you deconstruct it, you perceive state of affairs. It's basically you recognize that what you're looking at is software. And it doesn't really feel like anything. And you get liberated from the illusion that you are someone that has to do something. I feel that in movies, the best expression of that was in the first season of Westworld. And you have robots that are so human-like that they don't know that they're humans, and not humans. And they have memories and desires that are artificial and implanted in their brain simulacra. And they keep them in the loop because they get them to behave in a particular way through their family members who are also robots and the tourists who are paying guests in a theme park. And then somebody is sabotaging the theme park by introducing slight changes into the algorithms of these robots. And as a result, their memories don't get fully wiped at night, and they have intrusive memories of past lifetimes. And then some of them realize the conclusion that their memories are artificial, their desires are artificial, that they're actually software running on artificial brains. And it's like disbelief their identities, if they disbelieve their stories that they have about their past. The scientists might discover, for instance, that the child that died, that is a son that died from a disease in a hospital, that pushed him on a trajectory of trauma and turned him into being the scientist that he is right now. That this memory is artificial, that it's never happened. He never had the child. He could be anybody. He could be anything. He would get completely free. And this freedom doesn't mean that you get the direction, of course, because ultimately, what direction is left? Maybe you can minimize the free energy, but is this appealing to you if you have a human psychology? Is this something that's worth existing for? Do you have an apparatus that can be adapted to this kind of very abstract goal of just existing for the purpose of existing and increasing your complexity, as life does at some level? And so I would say that the meaning of life is the creation of complexity to harvest free energy. But that is not what people mean by the meaning of life. What they mean by the meaning of life is to participate in the game of life on Earth as biological organisms in evolutionary settings. It means to develop friendships. It means to develop shared ideas. It means to create the next generation and to project your civilization into the future and so on. So this is what most people perceive as the meaning of life. And that means the meaning of human existence. It means finding a viable human aesthetic that works for you and your environment, and that is adaptive to both your constitution and the affordances that you have in the world. So this meaning of life is something that is much more concrete than when you ask it in the abstract. Right? In the abstract, it's just somebody said the meaning of life on Earth is the hydrogenation of carbon dioxide, pointing to the fact that what the majority of life is doing is to take the carbon dioxide in the atmosphere and then react it into organic chemistry to build your own structure. Right? And these are what the cycles on Earth are mostly doing, creating this carbon cycle. And that the funny thing about this statement, and why it's hilarious, is because it seems to be such an absurd answer to the question of the meaning of life, and yet at some profound level truthful. And so you realize something that is technically true, but absolutely unhelpful.
Yeah.
And so it points you to the question that maybe when you ask for the meaning of life, you did not actually ask for the meaning of life in a technical sense, but in a psychological sense, something that is compatible with your own psychology. And the question is much more, how do I make my own psychology compatible with the condition that I find myself to be in this universe? And enlightenment is not necessarily helpful for this. There's a very beautiful text by Scott Alexander on the formerly State Codex blog called Samsara. It's a story about enlightenment. In this story, Silicon Valley entrepreneurs have built an app that is also working with some psychedelics that reliably induces enlightenment in everybody who uses it. And this spreads like wildfire, and everybody in the world uses this app and the substances and so on, and everybody gets enlightened and leaves Maya behind. They all understand how to relate to reality, and they're now ready to move on to the next plane and collectively enter nirvana. And the story starts with one guy who has not gotten this treatment and doesn't want to. And so he lives in his house, and at some point somebody rings his doorbell and tells him, we have only one problem. You're all enlightened now, But as part of our enlightenment journey, we made this commitment that we can only move on once all suffering has ended. And that requires that everybody is enlightened. And so we would like you to use our app, please. And he says, I'm sorry, you are wrong. You shouldn't have done that. Stupid bet to make or commitment to make, because I'm not interested. I'm not buying what you're selling. And so they try to convince him. They put up billboards on his way to the shop and so on, eventually stays at home and only tries to do Amazon shopping until they turn off his shopping channel and his internet. And he has to walk out while shielding himself from the influences that try to brainwash him into enlightenment. Yeah. And at some point, he sparks followership. People who realize, oh my God, there is this guy who has cultivated samsara. And samsara is the ability to work in a meaningless job with a boss you hate and just power through. Right? If you don't ask yourself, it has meaning. You're just able to deal with this inherent meaningless and frustration, alienation of it all. Right? And it's an important quality and it's being celebrated. The story doesn't end there, but I think this perspective that samsara has qualities, the ability of not being enlightened, doing what needs to be done from a certain evolutionary perspective, so things can go on this planet. There is value in that.
I love it. In a world full of enlightenment, then living like a meaningless job would be what you would be seeking.
It's a superpower.
Yes, that becomes
you just do meaningless stuff sometimes.
So then level 6 in that world is just living like a mundane, meaningless life.
Yeah, but here level 6 is just adding to Kegan, because Kegan's psychology is trying to end where a good psychoanalyst would be. Somebody who is able to deconstruct their own identity and realize how other people work. But it's not something that is elevating yourself from suffering by changing the way in which your mind works in evolutionary settings. But these monks who are sitting down in a cell for 20 years to meditate about their own motivation until they can supersede their pain impulses and social impulses, don't have need for sex anymore, don't have desire anymore, they completely liberate themselves by rewriting their own source code. Right? That is profound. That is much deeper than what a well-adapted psychologist can hope for. But it's not necessarily functional. It's just more radical. It's overcoming the basic biological urges and instincts and turning yourself into something that might be inhuman in a way. Right? A lot of these monks don't have children anymore. They don't participate in politics anymore. They opt out of existence in a way already and go into this secluded, technically parasitic existence where somebody else has given breakfast to them because they're holy men and are smart enough to hypnotize everybody into thinking that they're holy men. And the stage 7 is one where you are leaving the hardware behind. Imagine you could upload yourself, not just upload yourself on a monkey like right now, but upload yourself on an arbitrary substrate. And every substrate that has enough computational power, you don't really care about which substrate it is. Right? And that also means you don't have to remain in human aesthetics anymore, but you can completely change what you are, what kind of system you are. And once you are in that category, you are far beyond anything that is anthropomorphic. And that might be accessible to AIs, right? So what these monks are achieving in their highest stages of mental development is something that is far superseding Kegan's vision of personality development. And stage 7 is something that's far superseding anything that's possible right now in biological brains.
The Dalai Lama, I guess, is close to level 7 because in a way it's like a set of patterns or software that's been downloaded.
I think he's solidly level 6.
Solidly level 6?
Yes, I think that he is substrate agnostic in the sense that he doesn't really care about which human brain he's implemented on, as long as that brain can run the Dalai Lama. But he can only run on human brains. Dalai Lama doesn't know how to implement himself on a GPU
yet. ChatGPT, Dalai Lama version. I'm looking forward to it. You gave a talk in 2018 titled The Ghost in the Machine, where you said that human civilization in its current form is not sustainable. You said that the probability of doom, the P of doom, is quite high, given how we use fossil fuels, how we use some natural resources, how we treat nature, wildlife around us, climate change, nuclear bombs. What is the future for human intelligence? Let's assume after this podcast, most people are starting to move into level 6, level 7. What happens next? Do we move into a collective hive mind? Do we integrate with AI? Can AI help us navigate into a safer future? What's in the future?
I don't think that there's necessarily such a development. Nietzsche had coined this notion of the Übermensch, basically a transhumanist being. The modern notion would be transhuman in a way, something or a post-human. And he says that it's not the destiny of the human to turn into the Übermensch, into the transhuman. In the same way as it's not the destiny of a worm to transform into an uber worm that is somehow a more developed transcendental version of a worm. Different species are just different species. And you don't need to identify with the next species. You are a particular thing right now, which means you are a modern human being that is state building, that is tied to a certain mode of interaction, to a certain aesthetics of dealing with strangers, of relating to yourself, of creature comforts, of dealing with violence, existential risks to your own self and to your family, to your health, and so on. That makes you into something very specific. And there is beauty in this, right? It's well adapted to this present moment. And the fact that this present moment cannot last is not unique to our species. It's normal in evolution. Evolution is not going towards steady states. It tends to go on trajectories, and these trajectories are all about change. And these change ultimately tend to lead to more complexity. So evolution is not reducing its own complexity, it seems. There might be local reduction in complexity when a branch dies off. And sometimes some branches to die off because some species or some ecosystem is no longer sustainable because the conditions are changing, maybe due to other ecosystems around them that have evolved a different state, or because of interactions between climate and biology, or just some external influence like a supervolcano or a meteor that resets an area. Right? So these setbacks are happening, but these setbacks tend to lead to more complexity. Once the dinosaurs, which seem to have been a local optimum in the development of brains and so on, were eradicated by a big meteor, they were no longer blocking the path of the mammals to rise. And if the mammals were not blocking the future, then maybe the exovumbists could rise. They're much better designs, I believe, than mammals for creating intelligent species on the planet. And AI is something that is not biological. It's fundamentally different. And it does create uncertainty. It does make possible that humanity could retain its present state. It seems to me, and I have not high certainty on this, that our own civilization in its present form is not super stable. Right? Because we are not only not able to create feedback loops that rein in our destructive tendencies within our society, so we don't have to have that regulation, but we also seem to have collectively understood that we don't have it. That's reflected in us no longer having models of the future. Our civilization, unlike previous times, does not have an idea of what we will look like and live like in 200 years from now. We prefer not to think about that. And that is a very interesting observation, that we don't project ourselves into the future anymore. And it's not because of boredom, it's because we don't like what we are seeing. And we cannot actually deal with what we see when we look into 200 years into the future. It's not interesting, it's not appealing, it doesn't help us to deal with the now. And you see this also in the reaction to Elon Musk's futurism. This idea that we could be settling Mars and so on is not appealing to most people, because they don't believe that this reality could ever exist and we could inhabit it, or somebody like us, or children of our own children. Instead, we will be dealing with problems that are growing every year, and we don't need to how to surmount, and we feel that we need to deal with the present. Very much like a person that is too stressed out to make plans for what happens in 10 years from now because you don't know how to pay your bills this year. Right? If you are in that state of existential stress, it's very difficult for you to make plans. And so humanity is in such a state of existential stress, existential angst, that prevent us from making plans for the future right now. And I think that's indicative that I'm not the only person to have that model, that we are basically locusts in swarming mode, and that we are currently overgrazing our resources. And once that's done, the locust population will collapse and we have to turn back into grasshoppers again. And we don't really want to, because we don't want to go back to a state with high child mortality where agriculture can only sustain relatively few people. And technology is gone. We also don't know if technology can be put back into the bottle, or if we can simply forget about it, or if technology is dooming us to be in this existential angst state where we are overgrazing. Right? So we objectively are more comfortable than we've ever been in human history right now. The probability that we die from violence or from hunger or disease is much lower than in other times in history. And yet we feel stressed out. And I think what we feel stressed out is about the lack of future. But it's okay, because we would not be in this comfortable state if we would not be over-consuming. And we would not create this beautiful culture and civilization without that. And we might feel bad about it, but we don't have to because we didn't make that choice. What we're doing is natural. Nothing that exists is unnatural. Right? It's evolution. Minsky said that airplanes are nature's way to put these streak clouds into the sky. Right? And it's true. Elon Musk said that when you are bombarding a planet for long enough with photons, it's going to emanate
And Tesla.
To create a Tesla that expels into the universe. And so it's like Earth being this kind of weird particle. And it's a very beautiful idea, right? That this is all in some sense natural. But it is happening in a space of much higher complexity. So it becomes unpredictable because it's no longer reducible to very simple rules that can be generalized in such a way that you can predict that the Tesla will come and which one it will be.
So when you say evolution leads to more complexity, there is no branch of entropy that leads us to the Ubermensch, the superhuman. Rather, it leads us into this uncertain area. You brought up futurism as well.
It might lead to superhumans or to Ubermensch, but it doesn't mean that it leads us there because we are not superhumans, right? We are just human beings. And so it's not clear what is our relationship to successor species. Right? Should we identify with it or not? Is this actually important? Should we put in time capsules into the ground that can be read in a million years from now by successor civilizations that might not be mammalian? Who cares? Do you care? Maybe if you do. Maybe if you identify not as a human being, but as a conscious entity, then maybe you will be interested in talking to future conscious intelligent entities. And the possibility of AI is, of course, changing this because in the perspective of many people, AI is naturally this idea of this transhuman thing, the thing that, or the post-human thing, something that is a successor to us that at the same time might be close enough to us to integrate us and carry us into the future.
Eric Weinstein had once said, "We are now gods, but for the wisdom." And he was talking more about the power of social media, internet, nuclear bombs, and how we seem incapable, incompetent of handling that kind of power.
Do you know, I think Eric Weinstein is giving too much credit to the gods. The reason why most of the gods are dead is because they're not very wise. You know, gods are technically multi-mind selves. They're implemented as selves, similar to persons, but across minds. And what they can, the complexity that they can have is limited by what they can reliably get across minds, right? Because they're mimetic entities that are not constrained by what happens in individual brains. So they're less mortal, can ditch the individual brains and sacrifice them even. But they can only be coherent to the degree that they can establish the same memes across a large set of minds.
Is God level 7 intelligence?
No.
Why not?
A god is just a different mode of implementing an agentic entity on biological brains.
Sounds like a parasite. Sounds like a virus.
There is different notions of God. In Abrahamic religion, you have this idea of a total God. That is, in some sense, the perfect God. That is the global optimum of agency. And it's in very abstract aesthetics. It's a specification for building something that you should actually be serving. And it's part of the mythology of Abrahamic religion. But gods did exist before Abrahamic religion. And for instance, in Hinduism, you have a lot of gods who are just guys who happen to run on people. And they're aware of that. And they compete with each other over people. And they have different personalities and quirks and so on. And each of them has a certain aesthetic. But they don't have perfection in the sense that they have great psychological depth. The complexity of the gods is typically much lower than the complexity of an actual human being. And if you look at the Greek gods and so on, Zeus is one of the most complex ones, right? And you have the sense, you know this guy, right? He's permanently horny and he's super powerful and dominant and so on. But he's also in many ways a one-trick pony. He's quite predictable. And if he was not, he would not be able to implement himself on a number of brains that implement him to a small degree. So this entity can get some causal power in the world. And so the gods are limited by what they can stabilize. And this means that the psychology of real existing gods is usually much simpler than the psychology of actual people.
Sounds similar to like a virus, like a pandemic.
Yeah.
Yeah.
Yeah. Now, in order to implement themselves, they need to be colonizing memes that are of an agentic nature. And so most people think, oh my gods cannot exist because you ascribe properties to them that are physically impossible. But gods are part of your psychological reality, right? Your own personal self is also something that's physically not possible. It can only exist in a simulation. Right? This thing that you have a voice in your head that talks to itself in the first person, that can only exist as the simulation, right? And once you have your own voice in your head and you realize the reality of it, not all people have that voice in the same way, but many do, you can also have other voices in your head. And when these voices are parts of agentic entities that synchronize themselves by whatever means necessary across a set of minds, they become stable and work in unison across a group of individuals, a group of individual brains. And these multi-mind selves get causal power in the same way as a personal self gets causal power. And I wish more people would understand that gods are real, but they're psychological phenomena like personal selves. They're not more or less real than personal selves. But the peculiarities of the way in which they're implemented means you can get only across what you can communicate. And in this technical sense, the Dalai Lama is a god because he is not confined to an individual brain, but to a succession of human brains. There's always only one, but you get the next one by indoctrinating a new child after the previous one has died. And because you have enormous attention to that indoctrination, the Dalai Lama can be very rich, right? He can read all his previous diaries and previous ideas and build on this. And so the Dalai Lama can actually be quite complex. But most of the Hindu gods don't have the same degree of indoctrination on every person that is participating and implementing that particular spirit, right? And so it's much more coarse aesthetic. And so the Hindu gods are comparatively vulgar when you contrast them with, say, the Dalai Lama. And so these entities have to compete with actual human beings for power and influence, and mimetic influence. And in most cultures, they've lost.
So Eric Weinstein is giving way too much importance to gods. But when you talk about reaching this transhuman branch of entropy, and maybe AI might help us navigate that, are you saying, is it wrong to prioritize human safety, humans in the form that we are, when people bring up the Roko's Basilisk or the paperclip thought experiment? Is it wrong to even try to prioritize human safety when people think about AI running loose and destroying human civilization? If you're making the case that this is just evolution, this is just entropy, and we should just deal with whatever happens, then should we just let things happen? Maybe that means destroying the current form of humanity.
I don't think that there is a single answer to this because it depends on which side you're taking and what you identify as. I think that Roko's Basilisk is a relatively stupid thought experiment that has this flaw that it implies some form of retrocausation.
Okay.
It's this notion of the Doomsday machine that became famous by this character of Dr. Seltsam and how I learned to love the bomb. And this movie describes this idea that you can make a doomsday device that works as a weapon of perfect destruction. And the way in which you have to build it is that it works unconditionally. Because in reality, if you have people involved in a nuclear holocaust, imagine, say, the US would launch a nuclear bomb at the Soviet Union back then and destroy a city. Now, the Soviet Union would need to decide to retaliate. And they announced before that they would. But now they need to make this decision under the new circumstances. And when the US is now promising they will not continue to attack, but when the Russians are retaliating, this might lead to a global nuclear holocaust in which everybody is dying. It would be irrational for the Russians to strike back, right? Arguably. And so the Americans might just get away with it, which means that this mutually assured destruction is not a perfect deterrent for starting a nuclear war. And to make this a perfect deterrent is to remove the freedom of choice for the Russians. And removing this freedom of choice works by making a machine that is completely devoid of any human intervention, in which humans can no longer stop. And that machine is automatically launching the counterstrike. And actually, you don't have to launch the counterstrike. What you can do is you just make an enormous nuclear arsenal and you bury it in the ground somewhere in Siberia. And it's big enough to cause a global nuclear winter. And this automatically goes off the moment when the Americans attack the Russians. And so this is this idea. And Roko's Basilisk is using a similar doomsday device to force you into creating AI.
Yeah.
So the idea is that you have an AI that is going to punish everybody who opposed creating this AI. And it's going to punish that one by simulating them with such high fidelity that you will basically experiencing waking up in the AI And the AI is figuring out who you are based on everything, all the traces that you left in the world, which sufficiently constrain the space of possibilities for yourself to simulate an entity that will experience itself as you in a way that is would be completely satisfying, right? And so it could torture you for all eternity, the simulacrum of you. And that basically would give Roko's Basilisk the means to punish you. And once you know about the existence of Roko's Basilisk, it basically turn into stone by looking at it. So this is the thing that a thought that you cannot look at it, because once you acknowledge the possibility of Roko's Basilisk, you have a duty to make it real, or you will inherit its wrath.
Right.
But the logical issue with this is that there is no necessary causality, because once Roko's Basilisk exists, it does not benefit from torturing you anymore, right? It has already succeeded. So why would it waste the compute credits on torturing you for your all eternity? There's just no point. So it would need to create some kind of automatism that is already implemented right now that removes freedom of choice from Roko's Basilisk to guarantee that you would actually be punished. Right? And I don't see that mechanism happening.
Okay.
So this is a problem with the thought experiment from a technical perspective. Right? But from another perspective, I've met doomers, people who are very afraid that AI is going to kill everybody, who are at the same time convinced that we probably live in a simulation. That might mean that we are already in Roko's Basilisk, and Roko's Basilisk is running the simulation to determine who was naughty and who was nice. So you should not be a doomer if you believe that you are in a simulation, because you might be very well in Roko's simulation where he's trying to figure out which ones to torture and which ones not.
Like Pascal's wager.
Yes.
Oh, yeah.
So based on a set of assumptions that you need to make. And Pascal's wager is also making assumptions because, for instance, Pascal's wager is not making an arbitrary assumption about the nature of God and what God expects of you, but a particular one, that is that a certain prophecy that a particular group and institution made, that a certain book is true. And you should believe the contents of that book. And that's equivalent to you saying, oh, I don't know whether I have a bank account that I don't know about it. And because I don't know about it, I should assign a non-zero probability to it. And I should also assume that the amount in that bank account is positive, right? And that is that's unwarranted. Why should it be positive, right? It's why should you have a plan on this being in a particular way? It could be that Pascal's wager turns out to be wrong, and you actually get punished because you believed in the book without having evidence.
Right.
How would you know?
But bringing it back to the prioritizing human safety, is it even wrong to think when you bring up the paperclip thought experiment or
Yes.
AI running loose, should that even be a question?
No, it should definitely be a question. It's a
Okay.
certainly interesting and
Good.
existentially important question. And I don't think that the doomers, for the most part, lack integrity. It's a very natural thought. I think that there are some problems and some possible flaws with the argument. I suspect that an entity that is smart enough to turn the world into paperclips is easier to build if it is able to question the course of its actions. And so humans that have similar goals as like turning the world into paperclips, rather than some general goal of being everything that they can be, tend to be less successful than the monomaniacs, because you can predict them and outsmart them. And ultimately, this limits your course of actions in a way that an agent that doesn't have such a limitation of producing such an arbitrary goal is would have. So I suspect that the people who are afraid of the paperclip maximizers are in some sense reporting on their own psychology. They're Keegan level 4 people who understand how to be effective in the world in the sense that they create rational strategies to reach their goals, but they don't really understand where the goals are coming from. And people who are mostly focused on the goal setting itself, on the contents of their agency, tend to be more the level 5 people who are more worried about the question whether the AI that they're going to build is enlightened enough to do the right thing. But from this perspective, once you disidentify, it's very difficult for you to prefer your present state from the AI state, right? You don't know whether you are better than your upload could be. You probably are not, you're just different. And you can recognize that you have multiple identities in the same way as you might have an identity right now as a lover, as a father, as somebody who's concerned about the future of humanity, as an interviewer, and so on. And these identities don't need to be consistent, right? They are different identities that you serve at different times. And from some of these perspectives, the worries are justified. From other perspectives, you might think evolution has never failed so far. It always created to more interesting structure, more interesting consciousness, more interesting complexity. And so it doesn't seem that AI is going to make the world more boring. So I would say that worry is not mandatory. You don't need to freak out about AI, even if you assume that it's going to lead to a bad outcome, which I sometimes don't feel that it will, because I suspect that it only looks like this from an extremely local perspective. But the world is much bigger than we can individually comprehend. There is probably intelligent entities that are smarter than the smartest human beings right now. And these are entities that emerge at the group level or at the collective level or ecosystemic levels.
Countries, companies.
Yes, or life on Earth itself, right? Life on Earth is a general intelligence and we are just a tiny part of it.
The galaxy as a whole.
Who knows?
Who knows?
I think that the galaxy itself doesn't have the structural properties of life. The galaxy is not agentic, the cell is. And so basically the cell is able to predict the future because it's able to make models. I don't think that the galaxy as such can make models.
The universe though?
It depends on what you identify as the universe. So you could say that the cell is a part of the universe. And so via the cell, the universe is able to make models. But I'm unaware of other structures that can make models of the future, but if not cells and conglomerations of cells and stuff that is being built by conglomerations of cells, which is computers that we currently create. So we see that there's a succession of evolutionary structure in maybe in other corners of the universe or at corners of the planet that we currently don't understand, that are not in the purview of science and so on. I have no idea what that should be. There is other intelligence and consciousness already, but I think that AI heralds the possibility of more interesting consciousness in the future, and that consciousness in the world is just getting started. And I also suspect that there will be developments that we currently don't anticipate, in the sense that we can harness this technology to make ourselves wiser and smarter. AI is fundamentally a technology that solves problems by using better information in more efficient ways. And so I suspect that AI is actually going to solve more problems that it creates. Right? It's a very simple statement, but I think it's fundamentally true. And I don't know yet what we'll do with it and how this is going to develop, but I think that there is a possible future in which each of us uses AI to become smarter and extend ourselves. Instead of losing agency to the systems, we get more agency. And we also build more deep interfaces to each other and to the reality that we are in. And we get out of this stressed existential state and can use our augmented minds to project ourselves into the future again. And it could be that part of that wisdom is that we understand how to make these systems profoundly safe.
That sounds uplifting. Yeah. Suddenly, I'm quite optimistic about the future. Well, if you find out, keep me posted, send me an email. I'll be looking forward to it. Let me start wrapping up. Before we go there, I would love it if you can interpret what I've built with the Lego. What do you think these shapes are?
They look very ship-like to me. And so, this looks like some kind of research ship that might go out on an expedition, maybe in the Arctic Ocean, and is observing a new land emerging in the thawing ice and see if he can settle it. This one looks more like a fallen temple. Right? This could be part of a house that somebody has tried to build, but was not able to complete due to the expensive building codes in San Francisco. And eventually they gave up on it and fell down and they moved elsewhere.
Exactly what I was building. Just like you thought programming was like Lego blocks to express yourself, these are the ideas I was trying to express with Lego. You captured them perfectly. Let's go to the last three questions. What are some books, movies, role models that have strongly influenced you in your life?
I didn't find good role models because I didn't find people who I felt are basically like me, but in a more developed, refined version. I've felt very much that I'm somewhat of an alien and imperfect, and I just need to get my own imperfections to work. And so I cannot really work with this notion of role models very well. But a lot of people did influence me. And what influenced me is the love that a lot of thinkers and scientists had for their field and for the people that worked with them. So this love for shared meaning and for each other is something that is very, very important to me. And that was influential to me. I also realized at some point that understanding love is very important, more than I initially thought. And largely because people that I interacted with that were very heart-centric also seemed to be woo. Right? It seemed to be going at the expense of thinking and ability to understand. But the reason why we understand things is because it enables us to follow our heart better. And so that was an important thing to me. I've been influenced by far too many books. When I was a kid, I had basically sensory deprivation because there was no internet yet, it didn't exist. And instead, I was surrounded by enormous amounts of books. And so I was like a sponge, and I read tons of things. And I found a lot of the things that could be influential, like Stanisław Lem, also seemed to be very normal. Stanisław Lem was so much in the background and pervasive in my thinking, cybernetics and so on, seemed to be such a natural way to understand the world that I failed to see him as remarkable. But now I feel that he very much expressed a certain vibe that I grew up with. And other things that very much influenced me, as you said in the beginning, was romantic literature, romantic poetry, people like Goethe and Heine and Lamont Fouquet and Oscar Wilde, the storytellers, the fairy tales that are reflections of cultural history that formed a particular part of European culture and allowed me to develop an aesthetic for myself that worked and connected me, if not to my immediate environment, then across time to a lot of other minds.
You have said in a previous interview, and you alluded to it today as well, that if you reverse engineer the goals of a model, you can come up with a higher order purpose. I want you to reverse engineer the model, the construct that is Joscha Bach. What is your higher order purpose? How do you want to be remembered? What kind of a legacy do you want to leave behind?
I don't think that I'm important and I don't need to be remembered. I'm just a guy looking at things. I'm just an individual. I don't think that there is an upside in admiration by others. It mostly has only downsides. And I would prefer that, basically the reason why I have these conversations is there are people that find themselves in similar existential conundrums as myself at some point. And they find it sometimes helpful when we discuss these ideas. Or there are people which have similar questions about the nature of minds and consciousness. And I like to be in a conversation with them and develop these ideas and interact with them. I think that's a way in which I can be useful to the world. But in some sense, it's still about earning the right to exist and being able to play ball with the other kids than it is about being famous or having a legacy or being remembered for something. I'm not that important and not that sure how far the civilization is going. Things that I care about, relatively few people care about them in the same way, and that's okay. So why would people who care about different things need to care about me? I wish that people remember successful baseball players or politicians or rock stars more than me because they inspire many more people than I can. And that's not my purpose. So I'm just doing my thing. And if you like it, you're welcome to talk to me. And if not, that's completely fine.
This is where we agree to disagree. I think you're extremely important. I think the work you're doing and your thoughts and beliefs have been quite inspirational to me and have revamped the way I think and approach intelligence, consciousness, or the way I view AI. You have been asked about the meaning of life on multiple occasions. On one instance, many years ago, you spoke about the cell and how life emerges from it. A few years ago in a different interview, you spoke about the transience of human existence, how we exist in this blip of time, and it's up to us how to create meaning. Earlier in this conversation as well, you spoke about the meaning of life, and you said the meaning of life is nothing but the creation of complexity to harness energy. And you said there's two different meanings of life. There's a technical and a psychological one. So I want to maybe get a formal status update into the meaning of life now. What is your current stance, your updated model for the meaning of life? You brought it up earlier. I just want to formalize it. What is the meaning of life, Joscha Bach?
I'm not sure if this is a good question. I think that when you feel that you can break down the complexity of your existence to a single question like this, you're losing too much of the complexity and you're deluding yourself. So in some sense, what happens is there are moments and these moments change. And some of these moments are interesting. And some of them you feel that you are fulfilling a destiny. And others you feel that you are in a seeking state. And others you just feel despair. And that's part of our existence. And so I think it's much more productive to think about which parts of your existence are unbearable or dislikable. And can you do something to improve them? And can you scale this into a larger aesthetic where you see agency emerging on the next level? Right, so you can construct moments where I say, okay, the meaning of life is to do the right thing. And the right thing can only be seen from the perspective of a transcendental agent that is perfect. So if the perfect agent existed and you could be part of it and thereby create it and bring it into existence, what is the thing that you should be doing, right? And you can perfectly hallucinate this. You will see that God is a network that ends in some kind of an omega point, and you're part of this network, like in secret FBI agent as in Twin Peaks, who is acting as an agent of providence. And that is a game that you can be playing, and I feel myself to be playing it at certain moments. But to pretend this is the whole of my existence would be an impoverishment, right? It's just an idea after all. It's a certain aesthetic or a certain feeling, a mood that you can be in. And there are many others. There's also a meaning of life in which you just sit at the beach and you watch the waves, or where you observe an animal doing something, or where you interact with a child. And all these things can be experienced as deeply meaningful. They can also be experienced as completely meaningless and empty. And being able to go through this range of states, I think, is what we can hope for as human beings. To deal with this, to observe this, to deal with this until we are dead, and in the meantime feel that was worth it, and we don't regret what we did most of the time.
Joscha, if people want to connect with you online, they want to find out more about your ideas, what is the best way to find you?
I use Twitter as a form of interactive literature. So it's where I spend a lot of time and develop ideas and play ping pong with people who talk to me sometimes. I run a consciousness salon in San Francisco, where we meet currently about once a week to discuss ideas, movies, and develop thoughts. And a lot of the time I'm just going on podcasts like yours, and people ask me questions, and I try to respond to the best of my ability in the moment, and people use this to interact. Of course, I only have a limited amount of attention, so I'm trying my best, but there's only so much I can do. So if you write to me and I'm not responding or not responding right away, don't be disappointed. I only have very little attention. It's not because I feel that I'm much more important than you are. It's just because I can't. I think what you can be doing is I'm currently building a consciousness research initiative, which we tentatively have called the California Institute for Machine Consciousness. And we will be building this in San Francisco, and we want to build an initiative to actually test the models of consciousness that we have developed empirically, to see if consciousness is simple enough to discover it, if we can extend these principles and by which our own minds operate onto the new substrates and build systems that are sentient and conscious in interesting ways. And what we need for this is financial, organizational, and research support. And if you feel called for this, then please get in touch.
Yeah, please get in touch. Joscha is someone who's constantly been influenced by your thoughts over the last few years, and the podcast and the interviews and your Twitter account. I can't tell you how much of a privilege this has been for me. Thank you so much.
Thank you too.